This is a circuit diagram for a half wave, and here the settings of transformer primary winding and the transformer secondary winding, and the setting of the voltage in V sign. Everything I have explained in another video, and the link of that video is shared in the description box. Please go through that. Then only you can make the input voltage as 230 volts RMS voltage and 12 volts at the output of the transformer. So after going through that video, you will set all the voltages in a V sign, and you will get to 12 volts at the output of the secondary of the transformer. Then connect how to do this connection. Show you in a few minutes. Let me show the output first. So the diode is during positive half cycle, the diode conducts, and during negative half cycle, diode is reverse biased and it will not conduct, and we will get the output waveform in a CRO. Now, after clicking on the simulation, you go to debug and click on digital oscilloscope. I'll get the output waveform in this way. So this is the input waveform, sinusoidal input waveform, and this is output waveform. You can check out during positive half cycle, I got the output. During negative half cycle, there is no output. During positive half cycle, I got the output. During negative half cycle, there is no output. So in this way, I will get the output. But the very important thing in half wave rectifier is you should find out the efficiency and ripple factor and peak inverse voltage. So for all those things, you should find out what is the amount of DC voltage present in this component, output waveform, and how much AC is present. You should find out this. So for this, you should click on the cursor. So click on the cursor, then you place on the tip of the output waveform. Here it is showing 16 volts. Okay, so this is the maximum voltage. So take a notepad and you write down here. Sorry. So you write down here. So I already written VM is 16 volts. From this, we will calculate VRMS. In half wave rectifier, VRM is equal to VM by 2. So VM I am getting as 16 volts. 16 volts divided by 2 is 8 volts. So then what is VDC component present here? You just keep your cursor on this line. So you will get, I'll show you. Okay, so in order to find the DC voltage, two things you can do. One, you can measure from the cursor, and another thing you can measure from the shift in the DC. So what you should do, I'll turn off the input. I'll turn off the input. I'll take only the output signal here. I'll turn off the cursor also. Now, the baseline is here. Okay, exactly on this line. So when I keep my output to AC, the shifting takes place. So how much shifting? Earlier it was here, this line. Now it is in this line. Okay, so one unit has been shifted. Again, you can check. You place the cursor in DC mode. So you can check here. Now cursor is here. Line is here. It will go one unit up. See, it went one unit up. So one unit into the knob is at 5 volts. So the DC voltage is 1 into 5. 1 into 5. So it is equal to 5 volts. Okay, I got 5 volts. So now RF is calculated by using the formula. So using on the left side, you can check ripple factor is VRMS by VDC whole square minus 1. So the values what I got, these values I'll put in this formula, and ripple factor, theoretically, I should get 1.21 for half wave rectifier. Let me check in the calculator. So in calculator, so VRMS by VDC. What is VRMS? 8 volts. 8 volts divided by VDC is 5 volts is equal to, I got 1.6, and square of that 1.6 into 1.6, it is 2.56. So minus 1 is 1.56 under root. So I got 1.24 RMS ripple factor. This is the theoretical value. So this is my ripple factor for the half wave rectifier. Now we will calculate the efficiency. So the efficiency formula is here. VDC square by VRMS into 100. Okay. So VDC square by VRMS calculator I'll take. I'll clear the earlier one. VDC square is how much? 5 square is 25 divided by VRMS 68 square is 64 is equal to into 100 into 100. So how much I got? 39 point. Efficiency is equal to, I got is equal to 39.06 percentage. 39.06%. So the actual value is 40.1%. So it is very near to this. This is also correct. Then what is the peak inverse voltage? So the peak inverse voltage is, according to the formula, it is the maximum reverse voltage that can be applied across the reverse biased diode. So in half wave rectifier, the maximum reverse voltage is VM. VM is nothing but VRMS root 2. So now I'll clear the earlier one. So it root 2 is equal to sorry, 2 under 1.41 root 2 into VRMS into 8. So this is 11.313. So the maximum reverse voltage I can apply is 11.313. Okay. So this is all about how to calculate peak inverse voltage and ripple factor and efficiency for half wave rectifier. Now I'll show you how to construct half wave rectifier using a Proteus software. So first you should create a new project, click on new project. So after clicking new project, you just go on clicking next, 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 and finish. So the workspace will be opened. So in this workspace, you have to construct your circuit. And I have already explained how the half wave rectifier works during positive half cycle and during negative half cycle. So I have done a video on that. The link of that video is shared in the description box. So before doing this experiment, you watch that video, you will come to know that how the rectification takes place in using diode. After that, you open the Proteus software and you click on component mode. And here you search for, we need a transformer and a diode. So search for transformer. So here you should select the simple transformer. So click OK and place somewhere here, simple transformer. Okay, so the setting and all already I have explained in the previous video. So I have to connect one V source here. So click on V source. Okay, so click on this and place here. Then to measure this voltage, I need AC voltmeter. Click on AC voltmeter and place here and connect all these things to the primary of the transformer. And this also to the primary of the transformer. Now right click on this, click on edit properties. So how much voltage you should set? that already I have explained. So I'll show you now how much I should set to get in order to get 230 volts. So I should set some voltage in the V sinusoidal signal. That is 230 into root 2 is 325.27 voltage. I should set 325.27. So here you write 325.27 volts. 325.27 volts. Okay, click OK. Then for the secondary transformer, I need AC voltmeter to measure this because I want 12 volts output at the output of the secondary of the transformer. So for this purpose, I am connecting AC voltmeter. And in order to get 12 volts, I have to do the go to edit properties and change the primary inductance. So how much primary inductance I should select? So go here, bring this. Here this side, I'll take, see, to get 12 volt supply, I should make primary inductance as 367.5 hertz and secondary as 1 Henry, secondary as 1 hertz. So 367.5 hertz. So 367.5 hertz, 367.5, sorry, hertz, Henry, and in secondary is 1 Henry and click OK. Okay. And once again, you check 50 hertz you have set or not. So voltage is this much. Okay. So everything is over now. Next. This is V source. Sorry, this is V sign. I should connect V sign, not V source. Delete object. Search for V sign. Not V source, V sign. Click OK. Okay, click on edit properties. So how much I should set the voltage? Once again, I'll refer. It is 325.27. 325.27 and volts and frequency is 50 hertz. This is very important. Earlier I took V source and not, I need AC source. So I should select V sign. So now I want to connect one diode. So directly you can search 1N4007. 1N4007. Click OK. So place here. Then I need one resistor. Just type resistor. Okay. So resistor, you should primitive resistor you select. Generic resistor you can select. Generic resistor. Click OK. And place here. So click on this. Rotate anti-clockwise. Then connect the wire to anode from cathode to resistor and from resistor to ground, and select one ground here. Connect ground here. Okay. Next, you change the resistance value 1 to 1 kilo ohm. Okay. So now if you want to see the waveform, you should choose the virtual instrument oscilloscope and place here and connect the channel A to input voltage. Here you will get the input waveform, and channel B to resistor. Okay. So now you click on simulation. So you can do you see in CRO, you switch off channel C and switch off channel D, and vary some time division per knob. So blue one is output waveform and yellow one is a input waveform. This is about the CRO connection. And you can also check the voltage. At the input side, I'm getting 229, almost equal to 230 volts RMS, and output is 12 volts. So remaining thing I have explained earlier. This is about the construction of half-wave rectifier in a Proteus circuit. So after that, you turn off the simulation. If you want to zoom it, you can zoom it here. So you can see the waveform clearly. Then this is the virtual mode of doing experiment. In real mode, here I'll use 12 volts step down transformer. And here, instead of these two, I will have a 2-pin plug. So I'll connect 2-pin plug. And so I'll get 230 volts directly from the real transformer. Then one diode and one resistor and a real CRO you should connect. So remaining how to calculate ripple factor, efficiency, and peak inverse voltage. So already I have explained that. And so before watching this video, you first watch those two videos, then only you will clearly understand how the half-wave rectification works in Proteus.